We have two claims about the population, which we call the null hypothesis, H0, and the alternative hypothesis, HA. The alternative hypothesis challenges the null hypothesis and represents what we want to check, or what we suspect might be true. Our goal is to decide whether we can reject the null hypothesis and accept the alternative hypothesis or not. In order to do that, we obtain a random sample, collect relevant data, and summarize it. We mentioned that the data is summarized by a test statistic, but we haven't gone into any details about it yet. Based on the data, and in particular the test statistic, we find the p-value of the test. The probability of observing data like that observed with the null hypothesis H0 is true. Finally, based on the p-value, we draw our conclusions. When the p-value is small, in particular less than the significance level, which is most commonly chosen as 0.05, we conclude that the data provides significant evidence to reject the null hypothesis and accept the alternative. If the p-value is not small, we conclude that the data does not provide enough evidence to reject the null hypothesis, and so we cannot accept the alternative. Recall that we never conclude that we accept the null hypothesis, but just that we cannot reject it. This is an excellent opportunity to go back and look at the big picture of statistics, since the process of hypothesis testing is a great example of it. We want to learn about the population, so we obtain a random sample and collect data, summarize the data, and use probability to find the p-value so we can draw conclusions about the population. In other words, decide whether we can reject the null hypothesis or not.